Lian Li is launching its Lancool II for availability around December 20th, but review samples have been out for a while. After recognizing such high interest in this $90 case, we wanted to really deep dive with the qualitative and quantitative analysis, including additional thermal tests to really investigate the quality of the case. The Lancool I launched at a similar price, and we found the predecessor to today's review unit to be overall acceptable, if lacking versus Lian Li's 0011 dynamic. The upside is that the Lancool II looks nothing like the Lancool I, which isn't to slight against the Lancool I as much as it is a comment that we're not dealing with another boring, lazy refresh like many of the other case makers have committed to for this year. There's a lot to talk about today, including build quality, layout, attention to detail, and performance, so let's get started. Before that, this video is brought to you by the Gigabyte Z390 Aorus Master motherboard, which comes equipped with one of the more powerful Z390 VRMs for heavier overclocks. The Aorus Master is also one of the few motherboards with a real heatsink this generation, featuring a mix of high surface area fins and looks-oriented cover blocks. Oh, and it's also got updated RGB illumination. Learn more at the link below. So we need to set the expectations before we start on this. As is always the scenario with cases like this, where it's $90, makes it pretty affordable. It's got a lot of interesting features. We'll talk about the usefulness of them later, but a lot of really unique things like multiple doors, for example, technically hot swappable bays or drives, although we'll talk more about that later, and RGB LEDs, some ventilation. In a case like this, you'll get a lot of user commentary that's, this is the best case ever, or is this the best case ever? Could this be the best case ever? And let's just answer that question now and say, no. No, it's not the best case ever. And that's not to say bad things about the Lancool II out the gate. It's to establish that there's not presently and hopefully will never be a best case ever. Because if there's a best case ever, that means that the world of computers and enthusiast electronics has been confined down into one type of computer build, which is very boring. So we hope that there's never a best case ever, because then we have no more job and you have no more options in your builds. So just to get that out of the way, cases are interesting and fun and unique because they accommodate so many different styles of builds. You might have mini ITX. This is obviously not the best case ever for that. You might have a larger case, or you might just need different things than what's allowed for here. So no, this is not the best case ever, and we'll never see one, but at $90, it's very interesting. And there's a $5 increment for a white version of this case. We'll talk about the kind of the margin and how little we think Lian Li is probably making on this case relative to their others later, related to that number. But the biggest thing that gains points in our book is that this is not a simple sequel case to the Lancool I, where with the Lancool I, you had a very clearly different style altogether. And a lot of cases they'll refresh a product by adding a cable management bar or adding one more fan, and that's just boring. So Lian Li is already off to a good start by doing something more than that. There's a whole lot to talk about today. Patrick's written a massive build section talking about the quality of the case. I've noticed one more thing here while on camera, which is that over the past couple of days, this is no longer closing quite as flush. The bottom panel here, now I have to push it a little bit one more time to get it to close in, but it's also been opened dozens of times in a couple days, which is probably more than the life of most people's systems. Anyway, let's get into the build notes. There's a lot to talk about. Keep in mind that we take a critical look at things, so we'll talk about the annoying stuff as small as we can in detail to as large as we can in detail, and we'll talk about the really good things, and then we'll go through the thermals. The side panels are subdivided into two sections each. The bottom quarter or so below the level of the power supply shroud is steel and hinges down along the bottom edge of the case, and the top section above the power supply shroud is tempered glass and hinges back along the rear edge of the case. The glass sections can be lifted off of their hinge pins when opened, and the hinge pins are of unequal length, making indexing the door easier when replacing it. Closure for both sets of doors is magnetic, without any optional screws for secure transportation, so be careful lifting it. There's also no way to open the top set of glass doors without opening another panel first. There are no handles except on the steel doors, and the glass edges are nestled behind the other parts of the case, which makes it look sleek. It's really well done, but we'd appreciate a tiny cutout anywhere on the chassis to allow prying the glass open without first having to open the steel door. The hinges on the steel section are screwed into place and therefore not as easy to remove. At first we thought it was odd to have subdivided the panels like this, at least beyond the obvious marketing gimmick, as it just complicates everything. There are a few benefits though. First, since it's so short, the steel section can be opened even in confined spaces to allow access to the hot swap hard drive bays under the power supply shroud. Second, there are vents punched into the steel that can provide some air to fans mounted on top of the power supply shroud, vents that you can't punch into glass, so that's another benefit. The handle that we mentioned on the side panel is just a rim on the back edge that allows prying it out and works perfectly fine. The hot swap style sleds are a neat feature in this case, and especially for a case this cheap, but for them to be literally hot swappable as they're marketed, a backplane is required. And a free backplane only comes with pre-orders if the Newegg listings are any indication, and we aren't big fans of seeing video game style in-game pre-order rewards bleeding into physical products. Lian Li did ship us a backplane along with many other optional extras that cost more money, but we don't support pre-orders, and we wanted to test this case as it will actually ship for $90 after it releases, so we didn't install any of them. The hot swap feature is cool, but the usefulness of hot swapping drives in a desktop computer with a cage that can only hold 3 hard drives is sort of debatable. Maybe there are people out there who think they need this, but those who actually do need it have to be pretty rare. One example use case would be that you've configured a RAID 5 setup with 3 hard drives in your $90 case, and that you also have a drive fail within the life of the system, and that you also need to keep the system online while swapping in the replacement drive for a RAID rebuild. The odds of all of this happening are extremely unlikely. Technically, it's possible, though. The cage is removable, which would provide extra air to any of the fans on top of the power supply shroud if you don't need it, and it can also be repositioned within the shroud. Facing the case, drives eject to the left, opposite from the usual direction. The hard drive cage can't be flipped around to eject from the right, even though it looks like it would be possible with maybe one extra screw hole. We'd like to have seen that optional modularity added, as we couldn't identify a reason that it wouldn't be possible once that extra screw hole is added. The front fan and radiator tray is one of the high points of this case. Not only is it removable, but it can also be flipped around and repositioned a total of 4 different ways. And of course, fans can be installed on either the front or the back of the tray, so the tray fits into place snugly, it can be removed with 2 thumb screws, and it provides an excellent degree of flexibility with fan placement. Whether that's helpful in this specific case will be covered in the thermal section in terms of fans being closer or further from the front, but it's a good idea nonetheless. We greatly appreciate when cases make it possible to configure fans and radiators externally from the case, as it makes screwdriver access much straighter and quicker, and it's just way less frustrating than working inside of the case if you need to change something. This is especially useful if testing fitment of liquid cooling parts, either open or closed loop, prior to complete assembly. Lian Li can claim a job well done on this aspect of the case. Cable covers up next. These are often pointless. Cooler Master is especially prone to putting them in cases that don't need them. The Lancool II does need them, since both side panels are transparent and are held down by magnets, and the 2 large covers over the back of the motherboard tray do a good job of keeping things tied down and looking neat. Having 2 clear side panels doesn't look terrible for once. Between that, the Velcro tie points, the large and plentiful cutouts, and the big air gap between the power supply and the shroud, cable management in every part of this case was excellent. There's also a mysterious third cover over the back of the CPU socket. We gather from the manual that this is supposed to provide a mounting location for sticking on third-party RGB or fan hubs, which is a thoughtful touch considering that Lian Li doesn't use that mount for its own RGB controller. But in terms of cable management, Lian Li is up there with NZXT for this case. The front panel includes a combined audio jack, 2 USB 3.0 ports, and an optional USB 3.1 Type-C port. Optional here means that if your case doesn't come with the port, it still comes with an empty hole with a rubber plug in it. Maybe that's a positive since it allows the user to add their own cable later if they need it, but it would have been nice to have a recessed plastic blank instead of a hole. The front I/O also includes power and reset buttons and 2 rectangular buttons labeled C and M to control RGB color and mode. We appreciate good built-in RGB controls, even if these buttons are very obviously replacing what were 2 additional USB ports previously. It can also accept external ARGB control via a 5-volt connector if that's of preference. We rarely comment on the appearance of RGB effects anymore, but the lighting on the Lancool II's front panel is impressively bright, and even across both strips of mesh it remains bright. Buyers should be aware that the LEDs are integrated into the front panel, not the fans. RGB fans installed in the front of the case would be a waste, as they'd be hidden, so don't buy them. That also means that the stock fans are freely repositionable without ruining the lighting effects. This is one of the weak areas for cases like the Phanteks P400A Digital, because that case has ARGB fans that are intended to be installed in the front panel, and users who want to rearrange the stock fans to make room for a radiator or get better airflow are forced to break up the intended lighting. The front panel LEDs in the Lancool II are connected to the rest of the case with spring-loaded pins on the chassis. We like this system, but the metal contact pads have already gotten pretty scratched up, so it remains to be seen how durable it is. The C700M, as an example, also does this, but forces a means of indexing that protects the durability of the pins. So we need to see how many connection cycles they can survive. Now for the fit and finish problems that we mentioned earlier. Lian Li deserves a lot of credit up front for some very good panel fitment. The hinged glass panels are only directly attached to the case on one edge. So the fact that they swing shut and nest in place without catching or leaving large gaps is impressive. Not everyone does that. The same goes for the front panel, which is relatively easy to remove without being loose. The chassis itself is up to the standards we expect from Lian Li. The problems are with the little flourishes they've added, much like the fragile plastic snaps in the O11XL. The magnets that hold the steel panel sections shut are very brittle, and we're not magnet experts, but they might be neodymium. Either way, though, they are therefore tucked into the inside corners of the panels to protect the magnets from the case. Only one of the 4 steel panel magnets on our sample was positioned correctly when we received it, and the rest were left to slam against the chassis every time the door shuts. One had already been chipped by the time we received it before even using it. The hard drive sleds were another weak point here. They came loose during shipping, which isn't a big deal, but when replacing them, we noticed that 2 of the sled hinge pins were loose to the point of falling out. We hammered in 1 pin just to make sure that's how it was supposed to be assembled, and then we left the other one a little bit loose so we could show it on camera. Again, the hot swap idea is cool, but adding a fancy yet unnecessary feature to a case and then implementing it in the cheapest way possible pleases no one. Either commit to making this a budget case and lose some of the extra features and skip the optional add-ons, or make this a $200 case and go all in on quality to compete for the Phanteks Evolve X fans. This isn't to speak of the sleds themselves, by the way, wherein some of the cost savings become very apparent from the cheap nature of the thin plastic execution. But it's not like that matters too much from a functional perspective. Once you put the drives in, you leave them alone, so we can mostly ignore this point. Now it's time to move into the thermal and noise section, which is going to be incredibly dense for this case. Patrick and I worked together on analyzing the results here, and we have a lot of them. Because of the amount of buzz surrounding this case, we took our time and tested a few more configurations than we typically do. The case comes with 3 120mm fans installed as rear exhaust, top exhaust, and front intake. Beyond the usual set of tests, we tried moving the top fan to the front of the case, 2 intake, 1 exhaust, moving the top fan to the surface of the power supply shroud, 2 intake, 1 exhaust, and sticking all 3 fans on the front of the case for 3 intake. Since the fan tray can also be moved around, we further tried pushing it forward to get the fans a little more flush with the mesh filters. We already had enough variables to test that we didn't try removing the filters for a few other reasons too, but obviously thermals could be improved a little further by opting to do without filters. The one on the top of the case is unnecessary with the top exhaust configuration, for example, but the front filters are necessary for the lighting effects, so it's hard to imagine anyone choosing to do without the front filters. It's just, you buy a different case at that point. We'll start with only the Lancool II, and then we'll add other cases in a comparative chart. Starting with our normal torture workload, the stock case configuration maintained an average of 55.6 degrees Celsius delta T over ambient. Removing the front panel altogether lowered that average to 48.6 degrees over ambient, which isn't the biggest change we've seen from removing a front panel, but it's because there's also only 1 intake fan being restricted by it in the stock configuration, so the impact is lessened than one where we have an intake-heavy configuration. Moving the top exhaust fan to the surface of the power supply shroud had a predictably negative impact on CPU thermals, raising CPU average temperature to 61.5 degrees delta T, since in the top slot it functions as a CPU exhaust, but in the shroud it functions as GPU intake. More on that soon. Moving it to the front panel instead left the CPU temperature not significantly changed. In contrast, sticking all 3 fans to the front of the case benefited the CPU thermal slightly, lowering average down to 54.3 degrees over ambient, with the extra volume of cool air pumped through the case helping out. Moving the fans to be flush with the mesh filters normally wouldn't be a bad thing, and would help prevent some hot air from recirculating around the fans within the case, but this isn't a mesh-fronted case. 120mm fans actually fit completely within the space between the 2 vents, so moving them forward just puts them flush with an unventilated metal sheet. We'll show B-roll to illustrate this in case it's kind of hard to visualize if you haven't seen it, but that should point out why this scored the worst of all at 63.6 degrees over ambient. Relative to our other cases, 55.6 degrees for CPU temperature is on the warm side of the average, approximately equal to the Lancool 1. The Lancool 1 only comes with 2 fans though, where the Lian Li Lancool II has 2 out of its 3 total fans dedicated specifically to CPU cooling. It's not an especially impressive performance when compared to its predecessor, which already wasn't topping the charts. It's close to the Cooler Master NR600 and Nova Mesh TG as well, 2 mesh-fronted cases that only include 2 120 fans apiece and therefore don't have stellar stock performance. The front panel is optimized for LEDs first and thermal second. That's not necessarily a deal breaker for everyone, but it's important for you to be aware of if you really care about the thermal aspect. GPU thermals are next, focusing first on the Lancool only. The average GPU temperature for stock performance was 55.1 degrees over ambient. The best possible no front panel configuration was 48.6 degrees delta T, almost exactly mirroring the CPU deltas for these tests. Again, there's only one intake fan being affected by the removal of the front panel, and it's doing the job of both CPU and GPU intake. We expected moving the fan from the top of the case to GPU intake to help GPU thermals, since it's a direct intake fan placed right under the GPU die. However, this test averaged at 56 degrees Celsius GPU delta T over ambient, slightly worse than baseline. Fans placed on top of the power supply shroud have one real intake path only, and that's a small vent in the steel side panel, which means that it's both restricted and encouraged to recirculate some of the hot air through the empty fan slot next to it instead. Further, this vent is far enough that the static pressure requirement effectively guarantees no reasonable fan will be able to maintain pressure at that distance anyway. With the fan as exhaust at the top of the case, it doesn't directly benefit the GPU, but it's unrestricted and contributes more to the overall case airflow. Don't use the power supply shroud mounts at the expense of cooling elsewhere, and if you use them at all, probably put 2 fans in there so you don't recirculate air. Moving the top fan to the front panel instead left GPU delta T within margin of error of baseline, while moving all 3 fans to the front of the case was counterproductive with a warmer than baseline average of 56.5 degrees. The case isn't getting rid of the GPU's heat fast enough. There's really no great way to get a bunch of cool air to the GPU with just the stock fans. Moving the 3 fans up to be flush with the front panel, obviously the filter raised temperatures further to 58 degrees for the same reasons as described in the CPU section. Now for the comparative thermals. The GPU baseline was better than the Lancool 1 this time at 55 degrees versus 57 degrees. Not a big difference. It's not quite, but nearly error. Like the CPU thermals, 55 degrees is still on the warm side, and we had a hard time improving significantly over that average without additional fans. Air-cooled GPUs in this case deserve additional fans in the front panel or in the power supply shroud. There are definitely ways to move enough air through the Lancool II. It's just hard to get the job done with only the stock fans. 55 degrees is a bit warmer than the original H500P, which was terrible in most ways thermal, and equal to the stock Meshify C, which is also terrible if it doesn't have extra fans included or added to it by the user. Meshify C is pretty good once you actually add fans to it, but not stock. Our standardized fan test was added this year, but the chart continues to grow with each review. For this test, we replace all the stock fans with 3 Noctua fans, 2 140, 1 120, and ideally configure them as we did in this case. We set the 140s as intake, the 120 as exhaust, noting critically again that this test sometimes worsens performance for cases which are already well optimized for their stock configuration, especially for GPU thermals. This is thus far pretty rare, but it does happen. The Lancool II averaged 53 degrees CPU delta T over ambient with these fans, about 3 degrees cooler than the stock test. Compared to our other cases, that's still warmer than the median on par with the NZXT H500 or the ROG Strix Helios. The mesh-fronted cases like the Meshify C are generally cooler, but not incredibly so for some of the more restrictive ones like the 51.9 degree Nova Mesh TG. Standardized testing for the GPU is next. The GPU averaged 57 degrees over ambient, a couple degrees warmer than baseline. Forcing a straightforward front-to-back airflow pattern doesn't perform as well as the stock layout, as the negative pressure stock setup is encouraging airflow through the power supply shroud and the large holes in the back of the case, all feeding into the GPU cooler and up to the top of the case. Compared to our other tested cases, 57.4 degrees is definitely getting hot and about equals the S2 Vision RGB and is approaching the ENSO in the H500. Note that the H500 is one of the instances where the standardized fans actually hurt performance, as it's built for 2 200mm fans in the front. None of our tests with the stock fans, though, revealed an easy way to improve GPU temperatures for the Lancool II, so we'd recommend adding at least one more fan rather than trying to find a way to make the 3-fan configuration work. 3D Mark Firestrike Extreme stress test is GPU intensive and realistic to a game and workload, and our GPU averaged 53 degrees Celsius over ambient under this workload. That's close to the Thermaltake A500 and definitely much cooler than the Lancool 1's 60 degree average. Sometimes our 3D Mark stress test shows different results from torture due to the limited amount of heat generated by the CPU. And this is one of those instances. We mostly have the GPU generating heat, the Lancool II is capable of keeping up and cooling at an average level in this scenario. Blender rendering on the CPU averaged at 37 degrees over ambient, almost equal to the Lancool I, and relatively more competitive than the CPU temperatures from the combined torture test. Loading the CPU and GPU heavily at the same time seems to be what really overwhelms the Lancool II. Rendering with CUDA in Blender shifts the load to the GPU, so the 25.7 degree GPU result still lands in just about the middle of the chart and a couple degrees cooler than the Lancool I. We're now moving to noise testing, then noise-normalized testing after this. We'll first look at the noise-only chart with the case fan set to 100% speed and reportedly running around 1400 RPM. Case noise hit 42.8 dBA. That's noisy, especially for a case that doesn't have all 3 fans installed behind a mesh front panel. The nature of the Lancool II's front panel means that air will always be forced through weird angles and layers of filtration that will add to turbulence and noise with the high fan speeds that are required because of the flow impedance created by the front panel. So the fans should probably be running at those higher speeds in order to get and maintain the static pressure necessary to overcome the panel design. So this isn't a quiet case. Lowering the noise level to our 36 dBA threshold for noise-normalized testing required cutting the case fans to 60% speed in BIOS, or about 1000 to 1100 RPM. We leave the GPU and CPU fan speeds fixed and unmodified for this testing to allow us to better determine who has the most efficient assortment of fans and paneling, all mixed together without change from the actual bench itself. Thermals already weren't the best, but the speed reduction bumped our CPU up a lot, moving to 63 degrees over ambient, and GPU temperature moved up to 56.6 degrees delta T over ambient. That's almost the worst case on the noise normalized chart so far for CPU temperature, and it's pretty bad for GPU temperature as well, with only the ENSO, the Define S2 Vision, and the Elite outstripping it. Conclusions then. The Lian Li Lancool II is interesting because we have respect for the fact that it seems like Lian Li picked a price point, $90 or so, and really tried to stick to it. And I will confess that I saw this case a couple years ago when Lian Li was trying to collect the opinion of myself and of Der Bauer on what we thought of the case. And it was actually pretty similar. They did make some changes to it, some of them that we had encouraged, so that was really cool to see. But it was an early prototype from a couple years ago, and it's progressed now to a retail product. The interesting thing, though, is that when there's a white version at $95, and the base version at $90, what that tells us is that the margin on this is slimmer than the average case. And it makes sense if you think about it, because there's a lot of tooling involved in building a case like this. There's, again, I keep touching the multiple doors, but that is a cost that you don't normally have to account for. And anytime you deviate from standard design, you're adding to costs. It's all about machine time. The more time that the product takes on the machines to make, the more it costs, because you could instead make something else faster and do more volume. So 95, one of the things you learn in sort of retail psychology, and we've learned this through working in the industry for so long, is that if you price something at a $5 increment versus a $9.95 versus $99.99, the average user is not going to register a difference. And you might be better than the average user, and we fully expect that a lot of our audience is. But this basic marketing psychology does work on most people in the world, where if you see $99 versus $95 versus $90, for most people, it all looks the same. And whether it all looks like 90 or 100 probably just depends on your situation, but it all sort of looks the same. And a $5 difference, what I'm getting at is Lian Li could have easily charged $99.99 for the white version instead. But it looks like Lian Li really stuck to its guns and wanted a $90 case, to the extent that the added cost for white, and a white paint is more expensive. It's a hell of a lot harder to match white paint on multiple panels of different materials especially. So it is more expensive genuinely, but a $5 gap tells us that they're not making a ton of money on this case compared to their average cases, which is interesting. Doesn't really mean anything for the review, but it's fun to talk about. Features, Lian Li has packed a lot of features we'd associate with more expensive cases into a $90 package, but the implementation of those features is hit or miss. We really liked the hinged magnetic panels and the front fan tray. The front fan tray is not new. It's not a new idea, but it's excellently executed on this case, and it is something we really like from a standpoint of being able to test fit your water cooling components or just air cooling components before committing to something internally, at which point you're working at weird angles with a screwdriver in a cramped space, and that sucks. So the fan tray is really good here. The LEDs are nice for those who care about that sort of thing. The hot swap backplane and the USB-C port being optional extras is a big miss for us. We'd sooner see those features cut altogether than being done cheaply. If you're going to do it, do it well and don't half-ass it. Having an empty USB-shaped hole in the front of the panel is just sort of sad. Clearly, Lian Li has had to fight tooth and nail to hit that $90 price point. Again, if they're charging $5 for white paints instead of 10 or 0. And instead, we'd prefer that they got rid of things like the hot swap gimmick, commit to either including or eliminating the USB-C port, and take more care with assembly, whatever that ends up costing. On the other hand, the lackluster thermal performance is more forgivable at $90 than it would be at a more expensive price point. There are a lot of DLC add-ons for this case that aren't counted in the price. USB-C, for example. It's cool that Lian Li designed this in a way where you can add a USB-C cable later, but again, we'd kind of rather see it go one way or the other and just commit. We are big fans of committing to a firm decision with a product and not trying to make it do everything, because then it does a lot of things not quite as well as it could otherwise. So we're always big fans of picking one thing and doing that. And just like with our reviews, we try to pick a product and commit to it being good or bad and not being wishy-washy. Commentary on USB-C for you though. It's not cheap. So people like to throw numbers around like, oh, it must cost pennies for that in the manufacturing world. USB-C, we have a video on how it's made, and the cables, that is. And the USB Type-C cables, I'll just throw the numbers out there. I think it's been long enough. But they can cost almost $10. Cost. Not what you pay, what the manufacturer pays. That's insane. $10 cost is pretty high. So it can be as low as $3 or $4 for a Type-C cable with the rated speeds. But once you start adding in all the extra validation steps to make sure it actually transfers at those speeds before shipping the product and just throwing together a cable without validation, it gets closer to $7, $8. And that's expensive, and that's why you don't see it included in $90 cases. Or if you do, it's probably not validated as heavily. Thermal performance takes a back seat compared to the other features of the case. Overall, it's okay, but it's leaning towards warm, especially for a case that includes 3 fans. It doesn't do well thermally when compared to the rest of the stack, even at this price point. Buyers of this case should be interested in it for mostly the pretty lights. Maybe a very small percentage of you for the hot swap bays, but not for the airflow. The exception to this map performance is the number of fan mounts, which Lian Li has maximized for a case of its size. Fan rails that extend the whole height of the front panel for 120 and 140 mil spacing, 2 120 mil top mounts on the power supply shroud, and an unusually wide array of mounting options on the top panel are all above and beyond the usual options in a $90 mid-tower. Just make sure you keep the fans towards the back. Don't mount them up against the front panel because they will need some space to breathe. This is a case where to get better thermal performance out of it, you're going to need to spend enough where you can just buy a better case altogether. But if you are in love with the case visually, then that's something, I understand, personally speaking, I understand what it's like to be like, I have my heart set on this product, and damn it, I'm going to make it work. So you can make this work if you do want better thermal performance than what it affords stock, because it's just frankly not good stock. It is absolutely leaning towards bad for stock thermal performance. Features, we'd call the overall feature set and the overall build quality, especially at $90, to be good. So they're counter to each other. But you can make the thermal performance a bit better by filling in more of the fan mounts in the whole case. So if you get 2 more in the front, and if you want to use the bottom, make sure you saturate it with 2 fans as well, not just 1. Otherwise, you end up recirculating hot air through the adjacent fan hole. But you can kind of brute force it. You're never going to get as good as you could do in a case that's more open in the center. So this case, strictly speaking, is overall fine. It's got a lot of fit and finish issues that could be improved. However, we're willing to forgive most of those because it's trying to do things that most cases don't try to do. And there has to be a first step. And the second step will always be an improved iteration on that. So Lian Li gets a pass on a lot of the fit and finish issues, but we still point them out because they're important. Like the chips on the magnet, for example, this back magnet is already damaged. The door is no longer closing flush for this lower panel, even though it was fine a few days ago. And you could push it closed, not a big deal, but you get what we're saying here. Thermally, not good, but potentially acceptable depending on what you configure. And build quality and features overall, good. So that's the review of the case. It is not the best case ever, and hopefully there will never be a best case ever. But in the meantime, if you are interested in there's a very small subset of users that will want the hot swap feature in this specific type of case. You'll need to buy the extras for it, but if you want that, then this targets you. If you don't want that, there's still a lot of other cool stuff. And if you want thermals, buy something else altogether. It's as simple as that. And then finally, if you're looking for something that's a bit higher quality than this, not to say this is low quality, but if you want the next step up, then consider the Lian Li 011 Dynamic, which is a great case by the same company. In fact, that one we said was the best overall case for 2018, but not the best case ever because, well, it had flaws too, and it's also not accommodating for every build of all time. So there's your options. Plenty of stuff out there. Thanks for watching. Subscribe for more. Go to store.gamersnexus.net to help us out directly, like by buying our mod mats or toolkits, or go to patreon.com/gamersnexus to get behind-the-scenes videos. We just uploaded 2 Patrons Ask GN episodes that aren't on the main channel, and we'll see you all next time.